Hello everyone, this is the Developing China. Welcome to our channel. Today, we will discuss a topic with you. Today we will talk about the topic of advanced than TSMC, how mainland China win the chip game. When the United States saw the results of research and development, it proposed to share technology. China was also surprised by this. This technology has kept me in a leading position in the world's semiconductor industry. It successfully broke through the monopoly of Western countries, and at the same time broke through the limitations of the United States. This incident has inspired China to be beaten if you fall behind. In terms of policies, the Chinese government has published documents encouraging the development of integrated circuit chips and related chip industry chain enterprises, and has given them strong support and subsidies. Chinese semi-companies are specializing in semiconductor development. We all believe that they will ensure China's chip shortage and supply chain. Advanced than TSMC, how mainland China win the chip game. In the past, whatever type of chip, silicon-based semiconductor materials have been used without exception, because he has made the chip achieve a leap of 80 points from zero. But today's chip development has long been not satisfied with 80 points and wants to make new breakthroughs, but a major stumbling block for silicon-based semiconductors is Moore's Law. The so-called Moore's Law was proposed by Intel co-founder Gordon Moore. The limits of its chips are about to be reached, but 1 nanometer must not be the bottom line for people to study chips. At this time, it seems that there is only one solution to the problem facing the world, that is, to find new alternative materials. Whoever finds it first will take the lead in development. In recent years, the discussion about new materials has become more and more heated, and major chip manufacturers and related institutions are also actively looking for them, otherwise everyone will face the dilemma of not having chips. The first to find a breakthrough was the two-dimensional material discovered by TSMC, Delta, and the Massachusetts Institute of Technology. Combined with semi-metal coins, the MIT team first discovered that matching the electric stages of semi-metal coins on two-dimensional materials can greatly reduce the resistance and increase the transmission current. Subsequently, TSMC's Technical Research Department optimized the bismuth deposition process, and the National Taiwan University team used a helium-ion beam to successfully reduce the original channel to nanometer size with a lithography system. In the end, the research results achieved a breakthrough. It can be said that two-dimensional materials have high hopes in the industry, but the research has been carried out here, but it has faced even greater challenges. The problem is that the reserves of bismuth element are very small, and there are only a handful of mining areas around the world, and the process of refining high-purity bismuth element is very complicated, and the Western-style ductility is even worse. The difficulty is very high. It can be said that bismuth is not the best candidate for the development of cutting-edge chips. However, at this time, good news came from the scientific research team in China. In June last year, after the continuous research of the Yangping team of Yunnan University, a series of physical problems caused by chip materials were solved, the most important of which was to overcome the graphite functional defects of the alkene material itself. Starting from the knowledge of physics and chemistry, the scientific research team extended the area of platinum sulfide, a graphene-like material, under a suitable temperature and equal pressure environment, and achieved uniform transfer. As the foundation of the semiconductor industry, the performance of various materials determines the level of development of the domestic semiconductor industry. As the most basic inner material, graphene integrates optics, electricity, chemistry, and machinery. High-quality performance and widely used in the semiconductor industry. In order to fully release the high-quality characteristics of graphene and apply it to industrial production, it is necessary to find the most suitable development method. The current technology uses metal transitions, but the quality of graphene will change in the later stage and it will be contaminated. At the same time, graphene has problems such as low light absorption rate, which makes it difficult to be applied in more industries and products. Therefore, graphene-like materials begin to take his place. However, at present, most materials including graphene-like materials have the problem of small area and difficult to transfer. The platinum sulfide technology made by Yunnan University this time is to solve this problem. So what is this platinum sulfide? This compound, classified as a graphene-like material, can be used in the manufacture of chips, and its performance is much stronger than that of traditional graphene, and the performance of graphene is better than that of traditional silicon wafers, so this material is currently used in the production of chips. The optimal choice is to use carbon-based materials produced from graphene-like materials. The running speed is more than 10 times faster than that of silicon-based chips, and the power consumption is only 1/10 of the latter, so it has more advantages in use. Although the performance of carbon-based chips is higher, it also increases the difficulty of manufacturing several times. In addition, there are many impurities inside the material, which also brings unstable factors to the structure and performance of the chip. The platinum sulfide technology made by Yunnan University this time has further improved the efficiency of impurity removal, which has completely opened up the way for the application of new materials. This move not only solves the inherent problems of semiconductor materials, but also provides a new development idea for semiconductor materials for China and the world, laying the foundation for the future integration of new semiconductor materials. Not only that, the breakthrough in research and development of this material may help China's chip manufacturing level catch up with the top international standards. We all know that TSMC is the ceiling of the global chip foundry level. At present, in addition to competing with Samsung in the 3nm field, it is also seeking a breakthrough in 1nm chips. Compared with the bismuth element used by TSMC, platinum sulfide has a lower cost of use and higher production capacity, and most importantly, the application advantage is more obvious. So where is TSMC in 1nm R&D materials inferior to platinum sulfide? First of all, the reserves of bismuth used by TSMC are very small. The global reserves are only 330,000 tons, and the purification is difficult, and the process of injecting impurity buffer particles is slow, which will inevitably affect the application prospects in the semiconductor field. Compared with bismuth element, materials such as platinum sulfide are not the same. The reserve of raw materials is very large, which leads to extremely low price and cost, and the method of fusion development is very simple and can be developed more efficiently. The most important thing is that the performance of the developed products is very high. For example, the mature chips currently produced in China use Luhuabua materials, which can reach the level of more than 5 nanometers of traditional silicon-based chips, and even catch up with the 3nm process in terms of performance and energy consumption. If TSMC insists on using bismuth, it is hard to say whether it can develop a nanochip. If it uses platinum sulfide material, it will not only reduce the difficulty of research and development, but also shorten the research and development cycle, becoming the first company in the world to obtain a nanotechnology. Yunnan University's scientific research works can be said to open up broader application scenarios for China's semiconductor industry. Platinum sulfide is expected to become one of the key semiconductor materials in China to break through the blockade of advanced manufacturing processes, which is of great significance and will help us achieve the goal of independently producing high-end chips as soon as possible. Therefore, I believe that with the efforts of Chinese scientists, China's semiconductors will surely catch up with the world's most advanced level and achieve the overtake. We must accelerate the pace of the semiconductor industry, master core technologies, walk in the forefront, no longer be passive, and no longer be controlled by others. Thanks for having your watching in this video. As for this video, how do you feel in this video? You can add your ideas or suggestions in the comments below. Please keep following our channel and like our videos.